Hi, and welcome to a bite-sized tutorial. I've seen a few videos about minimaps in Unity, but almost all of them use a secondary camera to render a top-down view to a texture. And we don't want that. Instead, we will be using the world position of objects and the player to display their location on a custom map. This way we can keep the map lightweight, which helps with performance, and it's easier to customize for your game. And this is what we are working towards, a custom map with icons for the player, NPCs, and quests. We'll also make it dynamic, so you can have icons for whatever you wish, chests, key items, or food. What I will do for this tutorial is first grab a screenshot of my level in the scene view, where I can move my camera to the top here and set the rendering to orthographic with the square button to give me a perfect top-down view of my level. I'll also set the draw mode to unlit, because I won't be needing any shadows on my map. I will open up this screenshot in Photoshop, but feel free to use any image editing software of your choice, and quickly draw a rough outline of my level. Keep in mind that a minimap is rarely a perfect, realistic representation of your level, but rather a simplified version of it with only the essentials. Now, someone could use this outline to draw a proper map and know exactly where to put important objects, such as buildings. This someone is not me, so let's pretend that this is a good-looking map. I'll also create a few icons for the entities and export these to my Unity project together with my map. To display the map, let's start by creating a new, empty game object and naming it Map Manager. Next, right-click on the Map Manager and add a canvas. You'll find it under the UI category and call it Map Canvas. Now, inside the Map Canvas, right-click again and add a new image. Name this one Map Mask. This will later define the shape of the map and hide any parts we don't want to be visible. Add a mask component to this and I'm resizing it to 200 by 200. For the actual map, we'll create another image as a child of map mask, and you can assign your map texture to it. I'm resizing this to 400 by 400, and as you can see, the map mask now hides everything outside its bounds, showing only what's inside. These values might not work for you, so find the ones that do. Let's rename this object to Map Graphics to keep things organized. Finally, we need a place for the icons, so create a new empty game object inside Map Graphics and name it Map Icons. I'll grab the Map Mask object and place it in the bottom right corner. Now that we have a map, we can start creating the data containers. I will be using Scriptable objects for this, and if you're looking for a quick introduction to them, I will link to a video in the description. First, create a new folder called Scriptable Objects right here under Assets. Let's create the two scripts we need for this, Map Category and Map Entity Data. Open up Map Category and let's write some code. I'm using Unity 6, and if you're using another version or need help understanding scriptable objects, I'd recommend watching the video. It's a short one, and then make sure your script matches what I'm presenting here. I'll keep Map Category as the file name, and set minimap/category as the menu name. To keep this simple, I'm adding two variables, a private variable of type sprite called category icon, and another private variable of type color, simply called category color. Category icon is the symbol displayed on the map, and the category color simply determines the icon's color. These are private, but we are adding the serialized field attribute to expose them in the inspector. And we can add a public getter for both of them to make sure we can read the values in another class. Let's edit map entity data as well. Here, I'm keeping the file name as map entity data and set the menu name to minimap/entity data. The first variable I'm adding here is a reference to a map category, which allows us to define the specific category for this entity. We can just call it category. And as before, we are serializing the field and exposing a public getter for it. Let's also add a boolean called rotate with target. This is especially useful if you're representing your character as an arrow to indicate its direction, or if you want to show which way enemies or NPCs are currently facing. For this, we also need to set the rotate speed with a float for a smooth experience. These should have the serialized field attribute as well, and a public getter. And that is it for the scriptable objects. Back in Unity, let's create a script called Map Entity. We're going to attach this one to every entity that we want to be visible on the map, such as NPCs and quests. We need another one called Map Icon. This will be responsible for handling the visual representation of the entity on the map. Finally, we need a Map Manager script, which will basically manage the map and all the entities placed on it. Attach this script onto the map manager object we created earlier, which serves as the central manager for the map system. And while we are here, let's create a prefab for the map icon that we are going to start instantiating soon. To see what we are working with, let's right click on the map icons object and create a new image. Call it map icon. Change the color of this to make it more visible on the map and resize it. I'll go with 15 by 15. Next, let's drag the map icon script to this and right here, under assets, create a new folder called prefabs if you don't already have one. Drag the map icon object into it from the hierarchy and remove the original. Next, open up the map manager script and clean it up. We won't need the start and the update methods for now. Let's start by defining a static reference to the map manager and call it instance. Public static map manager instance. This allows us to implement a singleton pattern for the map manager to make sure only one instance can exist in the game. Next, we can set up the logic in the awake method. So let's type if instance is null. Meaning if there's no active instance of the map manager, we create one by typing instance equals this. We can also make sure the instance persists across scenes by typing don't destroy on load and pass gameObject as the argument. And if there already is an instance, we can remove this with destroy gameObject. Next, let's create two new methods, starting with register map entity. We want to return a map icon object from this method, so let's type public map icon register map entity. This takes a map entity object as a parameter. Next, let's create the unregister map entity method. Unlike the register map entity method, this returns void and takes map icon as its parameter. Now, we want to instantiate a prefab that will be the visual presentation of the entity. So, let's first add a variable up here, private gameObject icon prefab, and add the serialized field attribute here. Let's also add a private variable of type transform called icon parent and make it serialized as well. This is the map icons object we created earlier and we'll keep the icons in one place. And while we're at it, let's add a private variable of type rect transform called map image. It should also have the serialized field attribute. Let's also add two private transforms, bounce min and bounce max. Again, add the serialized field attribute to these. And finally, let's add a private transform up here called target with the serialized field attribute. This will be used as the target the map will follow, in this case the player. Back in the register map entity method, let's start by instantiating the icon object. Var icon equals instantiate, and within parentheses, let's define what we want to instantiate, the icon prefab, and then where we want to put it, as in its parent, icon parent. Now, we want to access the map icon component on it, so let's first check if it exists on the icon game object by typing if not icon.try_get_component with map icon in angle brackets and out var map icon in parentheses. If this condition is true, meaning the component is not found, we can destroy the game object with destroy icon. And if the component is found, we are assigning the component to the variable map icon we declare in the out parameter. We can finally return the map icon object down here. Now that we know that the icon is instantiated and that we have access to the map icon component, we can create a private list up here to keep track of our icons. First, add using system.collections.generic to the using statements section up here. Now, let's type private list with map icon in angle brackets, followed by icons equals new, opening and closing parentheses. We initialize the list with the new keyword, and because the type is already specified in the declaration, we don't have to define it again here. Let's add the icon to the list by modifying the register map entity method with icons.add map icon. Next, let's update our map entity script. I'm going for a clean start here by removing the start and the update methods for now. First, let's add a private reference to map entity data, call it data. Let's expose the field in inspector with the serialized field attribute. We're going to need access to this data later, so let's add a public getter here. Public map entity data, data, and return data. Let's also add a private reference to map icon, call it icon. Now, let's bring back the start method. We are going to register the entity in the map manager, which we do by calling mapmanager.instance.registerMapEntity. The method takes a map entity as its parameter, so we can pass this, which refers to the current instance of the class. This method also returns a map icon, so we can assign it to icon here. Now, when this entity gets removed, we also want to remove the icon. Let's add an onDisable method, and similar to the start method, we will call mapmanager.instance.unregisterMapEntity and pass in icon as the argument. Now, when we call registerMapEntity up here, it's not guaranteed to return a valid map icon object. If the prefab doesn't have the map icon component, the method will return null. So, let's add a quick null check in the onDisable method to avoid any errors. If icon is not null, unregister the icon object. That's it for the map entity script. Let's edit map icon now. As usual, I will clean the script up first. Let's add a private reference to a map entity object here. Private map entity entity. We are going to access this from the map manager, so let's add a public getter for it. Public map entity entity, and return the value of the variable here. Next, add a private field for the image component, named image. Make sure you have using unityengine.ui at the top in the using statements section. Now, let's add another private field for the rectTransform component, named rectTransform, which we can use to manage the UI element's position and size. We can now add an awake method, and inside it, initialize the image and the rectTransform variables. Start by initializing the image field with image equals getComponent with image in angle brackets. And then do the same for rectTransform. RectTransform equals getComponent with rectTransform in angle brackets. Next, let's add a new method called init. Public void init. This method takes a map entity as its parameter. Let's start by initializing the entity field with entity equals map entity. Now, let's set the icon sprite with image.sprite equals entity.data.category.category icon. Let's also set the color with image.color equals entity.data.category.category color. Now, for simplicity, let's add two new variables up here. A private boolean called rotate with target and a private float called rotate speed. In the init method, add rotate with target equals entity.data.rotate with target. And rotate speed equals entity.data.rotate speed. Next, we need a new method, public void setPosition, that takes a vector2 called position as its parameter. To set the position of the icon, we can type rectTransform.anchoredPosition equals position. Now, let's bring back the update method to handle the rotation. And first check if rotate with target to make sure this icon is even supposed to rotate. First, let's get the entity's rotation. Var entity rotation equals entity.transform.eulerangles.y. Next, let's continue with var target rotation equals quaternion.euler with 0 for the x, 0 for the y, and a negated entity rotation for z. And to actually rotate the icon, we can use rectTransform.localRotation equals quaternion.rotate towards. Set rectTransform.localRotation as the first argument, target rotation as the second, and for the third, use rotate speed multiplied by time.delta time. Let's add some final changes to the map manager before jumping back to Unity. First, in the registerMapEntity method, let's set the name of the instantiated object to keep track of them. This is a string interpolation, which allows you to insert variables directly into a string by placing a $sign before the quotation marks and placing the variable inside curly braces. Let's also initialize the icon with the init method we just created in the mapIcon object. MapIcon.init and pass in mapEntity. Now, let's scroll to the unregisterMapEntity method and simply remove the icon from the list when this method is called. Icons.remove mapIcon. Now, before getting too far, let's make some changes in Unity. Let's start with the boundaries, and for that we have a few options. What we are looking for are these points on the level, the bottom left corner and the top right. If your level is square like this, we could probably just do some basic math to get the points. But what if your level is wider, or maybe separated into 2 or multiple islands? Let's instead create a new empty game object in our map manager object and call it boundaries. In the boundaries object, create another empty game object called min and place it in the lower left corner of your level. Let's create a copy of this, rename it to max, and just place it in the top right corner. Now we can use these 2 points on the level to calculate the position of icons on the map. If you don't have one, create a data folder right here under assets. Because you could have other data categories, let's create a folder in it called Minimap. This folder needs 2 more folders, one called categories and one called entities. Let's start with a category. Right click here, go to create, Minimap and choose category. I'm starting with NPC, so for simplicity I'll just rename this to NPC, choose an icon and then the color. I'll create another one for the player, choose an arrow for this one as well and set the color. For variation, I'm creating a quest category as well. Choose the quest icon and set its color. Now, under entities, I'll create a data container by right-clicking here, choosing create, minimap and then entity data. I'll start with NPC, choose the category and make sure it rotates with the target. And for the speed, I'll set 360. I'll repeat the same for player and it should also rotate with the target. Finally, I'll create one for quests. This one does not rotate. Now, I'll add a map entity component to my player object and choose the player entity data file. I'll attach one to my NPC object here and one to my quest object. Select the map manager object in the hierarchy. Here, we can start dragging our object into the fields. My player goes into the target and the icon under prefabs here as the prefab. Map icons here is the icon parent and map graphics is the map image. And under boundaries we have min for bounce min and max for bounce max. We are ready for some more code, so let's open up Map Manager again. First, we want to convert the world position of a map entity into what I will call map position. Let's scroll down and add a new method. Private vector2 world to map position. This will take a vector3 called world position as its parameter. To get rid of this error for now, we can return vector2.0. Now we want normalized x and y values, so let's start with normalized x equals mathf.inverseLERP, where the first argument is bouncemin.position.x. The second one is bouncemax.position.x and the third one is worldPosition.x. Copy and paste this, but change x to y here and x to z here, here and here. Mathf.inverseLERP here takes the world position's x and z values and scales them down to a range between 0 and 1. So, if an entity is halfway between the bounds, the normalized value would be 0.5. Next, we need to convert these normalized values into the actual pixel position on the map. Starting with x. We do this by multiplying the x value by the width of the map, mapimage.sizedelta.x. Then, we subtract half the map's width, mapimage.sizedelta.x, divided by 2. This aligns the map center with the world 0 point. Copy and paste this for the y-axis, but change x to y here, 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 and here. Next, instead of returning vector2.0, we are going to return new vector2 with map x on the x-axis and map y on the y-axis. Now, let's bring back the update method here. Let's start with var mapPosition equals world to map position and pass in target.position. We're using the target position to follow the player. Next, type mapImage.anchoredPosition with a negated map position. This will update the position of the map according to the target's position. Let's now set the position of the icons, starting with a for each loop. For each var icon in icons. We want the position of the entity every icon is connected to, so let's type var position equals world to map position and pass in icon.entity.transform.position as the argument. To set the position, we can just type icon.setPosition and pass in position as its argument. Let's give it a try in Unity. Make sure you have no errors and hit play. You should now see the icons on the map, starting with the player here. If I move, the arrow should now not only follow my player's movement, but also rotation. Same with the NPC object here that's walking around in this room. And we can also see the quest object having an icon on the map. All good so far. Now, if you have a camera that rotates, you might want to rotate the map together with it. When we rotate the map, the items will rotate at the same time, but luckily this is an easy fix. This should work regardless of how your camera is set up, but I used my camera from a previous tutorial on this channel, link down in the description. Open up the Map Manager script again. The only thing we need to check is the camera rotation and apply it to our map. However, we need to make sure that the icons on the map also rotate correctly. So, in our Map Manager, let's start with a reference to our camera. Private, camera, main camera. This assumes you only have one camera that is set as your main camera, so in the awake method type main camera equals camera.main. You can also add a serialized field attribute to this and in Unity drag your camera to the field. Now, regardless of how your camera is set up here, the only thing we need is its rotation on the y-axis. Let's first create a simple method called setMapRotation and call it from the update method. We are going to be rotating the mask object, so let's add it below map image here. We are rotating it on its z-axis, using the y-axis from the camera. Scroll down to the setMapRotation method and type maskImage.localRotation equals quaternion.Euler, and within parentheses we are setting both the x and the y-axis to 0, since we are not rotating those. And finally for the z-axis we are getting the y-axis rotation of the camera. So main camera.transform.localRotation.EulerAngles.y. This means that when we rotate the camera on the y-axis, the minimap will rotate using the same value. This also means that the map icons on the minimap will rotate, since they are children of the map object. Let's open up the map icon and make some changes. Right below our setPosition method, let's add a new method called setRotation. This method will take one parameter of type float, and we'll call it rotation. To keep this simple, type rectTransform.localRotation equals quaternion.Euler with 0 on the x-axis, 0 on the y-axis, and a negated rotation as the z-axis. The idea behind negating the rotation value is to counter the map's rotation. For example, if you rotate the map by a negative 45 degrees, we want the map icon to rotate in the opposite direction by the same amount, 45 degrees, so that it stays correctly oriented on the map. Now, we only want this to occur if the rotation is not controlled by the entity, such as NPCs and the player, so let's add a check here. If rotate with target, return. Let's jump back to the Map Manager script to make some final changes. Here, in the update method where we set the position of the icons, we can also set the rotation. First, let's get the rotation of the map. var rotation equals maskImage.localRotation.EulerAngles.z. Now, we can just type icon.setRotation and pass in rotation as the argument. And that should be it for the code. Let's jump back into Unity to test this out. First, select the Map Manager and drag the mask object into the mask image field. Hit play and let's make sure everything works as expected. The map should rotate as I rotate my camera. Now, the whole map rotates, which we could solve with another mask object, but I will add a sprite to this mask in a bit. The player icon should not rotate, but rather keep looking forward until I rotate the character myself. Let's see what the NPC is up to, and we can see that he seems to be doing just fine. And so is the quest icon, always staying upright as I rotate the map. Now, there's some simple styling we could do with this map to make it more personalized. I could pick the mask object and set the source image to a circle, for a circular map. I could even add an image as a frame on top of it. You should now have a simple but easily customizable minimap that's not dependent on a second camera. If you have any questions, requests, or feedback, drop a comment or shoot me a message on Discord. The project is up on GitHub with a link down in the description. Thanks for watching, and I'll see you in the next one.